So welcome back, and we're going to continue with our study of trig equations, and we're hoping that you've tried these four. All right. So if you haven't tried them, pause the video and then give them a go. But let's take a look. So the first one, we're going to find our key angle. All right, and our key angle, remember, we're going to undo sine of 0,6. We're not going to put the negative into the calculator. Right, and let's see what that comes to. Right, so we get 36,9 degrees. 36,9 degrees. Okay, next up we say which quadrants do we want to be in if sine is negative, and we want to be in quadrants 3 and 4. So our general solution is going to be theta is 180 plus 36,9. That's going to be 216,9 plus 360k, right? Or theta could be 360 minus 36,9. That's going to be 323,1. Okay, and that is also going to have plus 360k. That is our general solution. Don't forget, whenever we write k, we must say k is an element of z. Okay, now, for this particular equation, there is no change in the period of the graph. So we're expecting 2 solutions per rotation, and there are 2 rotations. We're expecting 4 solutions, and those 4 solutions are going to come from taking 216,9. All right. That's with k equal to 0. If k is 1, we're going to add 360. We're going to get 576,9. If k is 2 and we add another 360, we're going to go outside there. So there are only 2 from that one. Now, the other possibilities are that we could have k being 0 in this one. So we'd get 323,1 degrees. Right? Or if k is 1 in this one, we're going to add 360. We're going to get 683,1 degrees. 683,1 degrees. And those are the 4 answers. Those are all of them. All right? There are no others. Okay. Right, let's turn our attention to the next one. The next one requires a little bit of work to start off with. We don't have the trig ratio on its own first, but this is just normal equation stuff. Let's subtract 3 from both sides. So 5 tan theta equals -1. Let's divide both sides by 5. So tan theta is -1/5. Next up, we're going to get our key angle. And remember, the key to finding a key, we're not going to put that negative into the calculator. So we're going to undo tan of 1/5. Shift tan of 1/5. All right? And remember, our key angle will be a positive acute angle. Let's see what it is. It's going to be shift tan of 1/5. We could type 0,2. All right? But it's 1/5. There we go. 11,3 degrees. Now, which quadrants do we want to be in if tan is going to be negative? And the answer to that is we want to be in quadrants 2 and 4. Remember, because it's tan, we can take either one of these answers and we can add 180k. So 180 minus 11,3, our angle is going to be 180 minus 11,3. That's 168,7 degrees plus 180k. Right, and don't forget k is an integer. Positive or negative whole numbers, or 0. Okay, now we've got 2 rotations here, no adjustment of the period, so once again we would expect 4 solutions. Let's see what they are. Theta could be 168,7, or we could add the 180, and if we add the 180 we get 348,7, right? We can't add another 180 without going outside of the domain here, but we can subtract 180. And in fact, we can actually subtract 180 twice. If we subtract 180 once, we get 168.7 minus 180 is negative 11.3. All right, and if we think about it, that's a quadrant 4 angle as well. So by 11.3 degrees, it makes sense. If we subtract another 180 from here, we're going to get minus 191.3 degrees. If we subtract another 180, we're going to go out the bottom end of that range. So those are all the solutions to this equation. Okay. Right. Notice how we're underlining our answers each time. It helps our teacher mark the work. Right. Now let's look at this next one. This next one is interesting because although we've only got one rotation here, we've actually got 3 times as many graphs as usual. So we will get 3 times as many solutions as usual. 3 times as many solutions as usual. Now normally we get 2 per 360. So now we're going to get 6 per 360. So we are actually looking for 6 answers. Right. First thing we're going to do, we're going to find our key angle. The key angle, we're just going to undo cos of a half. And when we undo cos of a half, we get 60 degrees. Which quadrants do we want to be in? That's right, first and fourth. That's where cos is positive. So one of our solutions is going to be 60 degrees. That's in quadrant 1. The other one's going to be 360 minus 60. Notice we only use the horizontal axis to generate these solutions. All right, and that could be plus 360k. And so could this one be plus 360k. And both of these are k, an element of the integers. Okay, now, just be careful. That's not theta. That is, in fact, 3 theta. And this is where our extra solutions are going to come from. Because this 3 theta, when we divide through by 3, instead of adding 360k, we're going to add 120k. We're going to get more solutions than usual, right? We're going to get theta is 20 degrees when we divide through by 3, plus 120k. And here we're going to get 100 degrees plus 120k. Let's see how many solutions we can find. If, on this top one, if k can't be negative, all right? Otherwise we're going to be subtracting, we're going to go outside the bottom end there. But if k is 0, we get 20. If k is 1, and we add 120, we get 240. Sorry, if we add 120, we don't get 240 at all. If we add 120 to 20, we get 140. If we add another 120, we get 260. If we add another 120, we get 380. That's too big. So those are the only 3 that are going to come from the top one, but there are going to be 3 more from the bottom one. If we don't add anything, we get 100. If we add 120 to 100, we get 220. And if we add 120 to 220, we get 340. Okay, and those are our 6 solutions. Okay, 3 times more than usual in a rotation. Okay, right. Let's now look at this one. Like the other one, it has a different period. We're going to get twice as many graphs as usual here. So we would expect 4 solutions per rotation, and this is a full rotation. From negative 180 to 180 is 360 degrees. So we're expecting 4 solutions here. Okay, we're going to get them via a general solution first. The first thing we're going to do is we're going to find our key angle. Right, our key, we're going to undo sine of the square root of 3 over 2. It happens to be a special angle. It happens to be 60 degrees. Which quadrants do we want to be in? Well, for sine to be positive, we want to be in those 2. One of our answers is going to be 60 degrees. That's in quadrant 1. That's 0 plus the key. The other one, remember, we only use the horizontal axis, 180 minus the key, 120 degrees. To each of them, we can add 360 as often as we like, as long as we are adding a whole number of lots of 360, positive or negative. In other words, k must be an integer. Now, only now do we say, hang on, That's not our angle. That's actually, well, that is our angle, but our angle is 2 theta minus 15 degrees. Okay, and this one's 2 theta minus 15 degrees. From here, it's just algebra. We're now going to solve each of those two equations. The top one, we add 15, we get 75. All right, when we divide 75 by 2, we get 37,5. But don't forget that the 360 must now become 180k. The bottom one, we get 135. And when we divide 135 by 2, we get 67,5. No, we don't. 135, 67,5. Yeah. All right. Just checking myself that is right. Okay, and that one will also be 180k. 135 divided by 2 is 67,5, 180k. Right, and then the last thing we do is we write down our specific solutions. So, if k is 0, we get 37,5. If we add 180, we're going to go outside the top. But if we subtract 180, right, 37,5 minus 180, we're actually going to get 142,5 negative. All right? If we take this one, 67,5, all right, we can't add 180, but we can subtract 180, and we get minus 122, no, not 122, 112. So let me just make that a bit neater. 112,5 degrees. Okay, and there's our solutions. Right. Okay, let's now have a look at some different types of questions. So the different types of questions is different, the whole range of different things, but often what happens is we end up with sine and cos in the same equation. Now, if we have sine and cos in the same equation, both operating on the same angles, then we can divide both sides by cos to get tan. Let's have a look at this, okay? So, we've got the same angles, and so what we're going to do is we're going to divide both sides by cos 2 theta. So this is going to be 3 sine 2 theta over cos 2 theta. And this, on this side, when we divide by cos 2 theta, we're just left with minus 5. Next up, we divide both sides by 3. But remember that sine divided by cos is tan. So what we've actually now got is tan 2 theta is negative 5 over 3. And this is what I call a vanilla flavored trig equation. It's actually quite straightforward from here. Now we can proceed exactly as normal. We know our answers are going to be in quadrant. For tan to be negative, quadrant 2 and 4. We need a key angle. Let's pull up a calculator to get our key. Alright, so shift tan. So shift tan of 5 over 3. Remember, we don't put the negative into the calculator for the key angle. 5 divided by 3. And we get about 59 degrees. Okay? I'm just going to round it to 59 degrees. So that's our key angle. Our key is 59 degrees. And now, sorry, this is not tan theta, this is tan 2 theta. Right, so now we know we want to be in quadrant 2, so 180 minus 59, 121 degrees, plus 180k. And the reason it's 180k is tan. That's going to take us into quadrant 4 if we add 180 once. Okay, right, now let's have a look. This is not theta, this is 2 theta. So in fact, theta will be 60,5 degrees plus 90k. And that will generate all the solutions that we need. Remembering that k, we must say that k is an integer. Okay, right, so let's see. Okay, we're expecting twice as many solutions as usual. There's one rotation, so we're actually expecting 4 solutions. And let's see what they are. All of them are in fact negative. So if we take 60,5 and we subtract 90, now let's just show you how we can do this on a calculator, okay? So we're just going to go 60,5 and we're going to minus 90. All right, and we get negative 29,5. Negative 29,5. So there's one of our answers, negative 29,5. Or, now, if we bring our calculator back, and we just minus another 90, we'll get the next answer. We're now at minus 119,5. All right, minus 119,5. Or let's minus another 90. So we can just keep on going on our calculator. Minus another 90. And we get minus 209,5. All right? Or let's minus another 90. So we just keep on going. Minus 90. And we get minus 299,5. Minus 299,5. And notice that if we minus another 90, we actually now get an answer, but it's not an answer because it's outside of the domain of the question. So those are our 4 solutions to this question. Okay, so what have we done differently here? Well, we've set off with an equation that's got sine and cos in it, in the same equation, acting on the same angle. And this is really important because next time we're going to look at ones where they're not acting on the same angle. Let's try this one. So what we're going to do here is we're going to divide both sides by cos. That gives us tan theta on this side. And we're going to divide both sides by 3. So tan theta is minus 4 over 3. Now that is what I like to call vanilla. It's just a plain, straightforward trig equation. We want answers in that quadrant and that quadrant. All right. We need a key angle. Remember, when we find the key, we're not going to put the negative in. We're going to just go shift tan of 4 divided by 3. And we get about 53,1 degrees. Okay, 53,1 degrees. Our key is 53,1 degrees. Now, 180 minus 53,1 is going to be 126,9 degrees. 180 minus 53,1, 126,9 degrees. Because it's tan, we can go plus 180k. And there is our answer. Theta is that. And don't forget, we must say, k is an element of z. Okay, and that's our answer. Right, let's do this last one. Last one before, maybe you guys can try this one. Okay, and pause the video, try it, and then we'll let it play and see how you went. Okay, so we're going to divide both sides by cos of 2 theta plus 12. The important thing here is that both of these angles are the same. So when you divide sine of something by cos of the same thing, you're going to get tan of that thing. So you're going to get tan of 2 theta plus 12 equals, and we're going to divide both sides by 2, we get equals 2. Next up, we want it, this is vanilla. This is an easy, straightforward trig equation. Standard. And we're now going to find our key angle. We're going to undo tan of 2, shift tan of 2, and we get 63,4 degrees. Okay, next up, which quadrants do we want to be if tan's positive? Well, we want to be in quadrant 1 and quadrant 3. Remember, because it's tan, we only need one of those answers. There's 63,4 degrees. Okay, and we are going to add 180k. 63,4 plus 180k. And remember, k is an integer. Okay, now the last thing we need to realize is actually our angle is 2 theta plus 12. So now we write 2 theta plus 12 is that, and now we solve. When we subtract 12 degrees from both sides, we get 51,4 degrees. Okay, and that's 2 theta. So now we divide both sides by 2, All right, so we get 51.4 over 2 plus 90k. And there is our final answer. Okay, right, that's it for this time. In the next lesson, we're going to look at examples where we don't have the same angle, so we can't use this trick. Okay, we look forward to seeing you next time to try those.